Congratulations on making it to the third and final video for chapter 1. Now we have talked about all of these topics and we only have 3 topics left. Remember the different areas of psychological research like biopsych and social psych, different sources of knowledge like the source from authority, the importance of critical thinking, and the pseudosciences and what separates us from a pseudoscience, applied research like knowing where to put buttons on stoves and things like that, the goals of science and the different research methods needed to attain those different goals. Today, or here in this video, we'll talk about doing science and proof and disproof and the research process. I actually am going to switch 8 and 9 and we'll talk about the research process before proof and disproof, but so it goes. This is the order they are in the chapter. I changed it up at the last minute for this lecture though. Hope that's not too confusing. Okay, first, doing science. That's what this whole chapter is about, right? It's about thinking like a scientist and doing scientific work. One really important thing about doing scientific study is that it's a given that you're going to need to do it again. Like you always do your studies more than once because you're never going to control all of the different factors. And it's just good to look at things from a number of different angles, right? Like as many perspectives as we can have on something, the better understanding we'll have of it. So that's always helpful too. And it's the real world, so nothing's ideal, and we have technical limitations. And I guess this last point goes along with having as many views on things as possible. So theories change over time, and they become more and more developed, and more people get on board when a theory starts moving, and it's a pretty awesome thing. And that brings us to this concept of the research process. And there's a number of different ways you can break down the empirical cycle, but this is how this chapter breaks it down. You identify a problem. So what's going on with the problem? And then you review the literature. Based on what you've read, what other people have done, you'll come up with your own hypothesis, and then you'll design and conduct a study. After that, you'll go ahead, analyze and interpret the results, do some statistics on them, and see what it means for your hypothesis, decide whether or not to accept or reject your null hypothesis, and then you publish whatever you found. And this should be transparent enough so other people can replicate everything that you've done so far. And then you get back to finding a new problem. Maybe whatever wasn't perfect about your study, because your study is never going to be perfect, then that's a whole nother problem. That's a whole nother thing that you can investigate. And then you go around and around. So it's more like a spiral than a circle, though, because you are making advances. So it's important to keep that in mind. You're not just running around like a cat chasing its tail, or a dog chasing its tail, whatever animal chases its tail. Okay, so again, if you want more information about this, you can consult your textbook, as always. Finally, we'll finish off with this concept of proof and disproof. When you do an experiment, you always want to be seeking to disprove a theory, and your hypothesis always needs to be something that's falsifiable. Remember, that was in the second video. So I'm going to go kind of out on a tangent here, but I think it's kind of interesting, and maybe it'll help to really grasp this idea. I think the textbook talks a little bit about this too. This is a task. It's called the Wason selection task. And in this task, people are given these 4 cards. Just pretend that this is a card. And they're told this rule. If a card has a vowel on one side, then it has an even number on the other side. So it has a vowel on one side, then it will have an even number on the other side. Now, what I'm going to show you is the confirmation bias, which is that we tend to seek out information that will confirm what we already know or what we've been told. So I'm about to give you the answer, so if you don't want it yet, you can pause the video. But most people will answer to this A and 4, and that is not the right answer. Okay, because what you need to do, though, is figure out what's the fewest amount of cards that you can turn over to see if this rule is true or not. And so because the rule has the words vowel and an even number on it, that's just what you automatically go to, is you say, okay, well, let me flip over the vowel and the even number and see if that's true on both of them. But you need to think of it as someone looking for evidence to disprove the statement. Before we get to that, I will show you why that A and 4 are not is not the correct answer. But it is 2 cards. It's not A and 4, though. You do need to turn over more than 1 card. Okay, so if it has a vowel on one side, it has to have an even number on the other side. We want to know if that's true. A, okay, so what if we flip it over and we get a 2? Then that would mean that so far that statement is true. If we get a 3, though, then that would mean that the statement was wrong. So the A is something that we should flip over. Check. Okay, it's a really pathetic looking check mark, but it's going to have to do. Check. It's very hard to draw with this. Okay. Check. Alright, so A is something that we do need to flip over. What about the K? Not many people say the K, but I'll show you. Okay, so if it has a vowel on one side, it has an even number on the other side. What if the K has a 2? We don't really care. What if it has a J? We don't care. If it has a percent sign, we don't care. If it has a smiley, still, it's kind of cool, but we don't care that much because it doesn't have anything to do with this rule. Okay, so the K does not matter. No. Doesn't matter. Okay, what about the 4? If it has an E, if it has a vowel on one side, then it has an even number on the other side. But this statement doesn't say that every time it has it says every time it has a vowel, the other side has to have an even number. But it doesn't say anything about if it has an even number. If it has it could have 2 even numbers, right? That doesn't violate that rule. So if the 4 had a 2, it still has no bearing on this rule. We don't really care. I mean, it's still, this rule could still be true if the 4 had a 2 on the other side. So the 4 is not a card to flip over. I'll draw a pathetic looking X over this. Now what about the 7 though? If the 7 has an E, then that does show a violation of the rule. So we have detected, so this does have bearing on whether or not that rule is true. Because it's this one, the 7, and the A tell us those are the 2 situations where the rule could be broken. So we need to look for cheating situations, or places where the rule would be violated. Okay. All right. So if we're looking for things where we're trying to disprove things, then we're more likely to get to the truth more quickly and more concisely. And with practice, we get much better at disproving theories. Okay. So to give you an example of that, this AK47, less than a third of people get this correct, that you need to flip over the A and the 7. Less than a third of people. But if I change this around to a situation where you're more familiar with trying to detect cheaters, then you'll drastically improve. So this is a really good example. We say somebody's drinking a beer, somebody's drinking a Coke, somebody else is 22 years old, and another person is 16 years old. And here the rule is, yes, you guessed it. If a person is drinking alcohol, then the person is 21 or over. So it's real easy to see in this situation that we need to know how old this person is. Okay, so this is directly parallel to the A. Oh, it's really hard to draw with this. A. If they're drinking a Coke, that's the K. We don't care how old they are. It doesn't matter. They could be an alien. Doesn't matter to this rule. If they're 22 years old, we don't care what they're drinking. Just like the 4. Just if a person's drinking alcohol, then the person is 21 or over. But that doesn't mean that everyone who's 21 or over has to be drinking alcohol. So that goes just like the number 4, right? So we don't care what this person's drinking. Come on, Jeff. But this one would be like the number 7 in the Wayson selection task. And so we do need to find out what this 16-year-old is drinking, because if this 16-year-old is drinking beer, then they're violating a rule. Okay, sorry for this awful penmanship. Maybe I'll get better at it. Okay, so that's a really concrete example, hopefully, of how falsifying information is an important practice, and it helps you to get to the truth more quickly, and you get better at it with practice. And that's all because of the confirmation bias, and this task is the Wayson selection task. So in sum of the chapter, the scientific method uses empiricism and rationalism, and we use science to describe, predict, and explain. The only way you can get cause and effect relationships, the only way you can get to this explanation is with an experimental method, and you need to try to falsify a hypothesis when you test it. Okay, have a great week, and thanks for watching all of the videos. Bye.